All right, good morning, everyone. It's Ty from Lambda School, and today I'll be going over the coding challenge, rotated array. All right. Don't need that. Don't need that. Cool. So given a sorted array that has been rotated some number of times, some number of items left or right, in example, 0, 1, 2, 3, 4, 5, 6, 7 might become 4, 5, 6, 7, 0, 1, 2, 3. How can you efficiently find an element? For simplicity, you may assume that there are no duplicate items in the array. Rotated array search should return the index of the element, if it is in the array, and should return null otherwise. For instance, if you call rotated array search on the array 4, 5, 6, 0, 1, 2, 3, comma 2, so your two arguments are 1, the array, and 2, the number you're looking for in the array, it should return index number 5. So 0, 1, 2, 3, 4, 5. The fifth index is the sixth item in the array, but the fifth index is the number 2. And then if we call rotated array search on the same array, but we give it a number 100 instead of the 2, it should return null. And the target time complexity is O log n. All right. Can y'all think of any edge cases for this? There might not be any. Given the ordered list and the offset, yeah, I don't see any edge cases either. It's always important to think of it, but don't spend 50 minutes thinking about edge cases. Just, the ones that really come to mind after about 5 minutes of thought. Anything past that is a super special edge case, and you sort of deal with it when you get to it, right? Because we already know that there's no repeated numbers. What would be an edge case potentially in this scenario? Well, they nullify the only big edge case that I was worried about, which is the duplicate elements in array. I guess another edge case, no. I really can't think of any. That's why I was actually asking the course tag. The question from Tig was, can you give an example of what an edge case potentially would be in this scenario? And no, I can't, but it's always important to think about it. All right, so we know we need const rotated array search to take in an array and a element index. No, I don't like that term. Number, sure. Equals arrow symbol, semicolon. Cool. So, well, you could still do it with string. Oops. No, I don't need that. Because you can sort an array of strings like that. So you can sort one. Yeah, that could be an edge case. We will definitely have to test for that. So Patrick said, I suppose one would be a consecutive set of integers versus one with gaps. An example, 4, 5, 6, 0, 1, 2, 3 versus 4, 6, 9, 1, 3. Totally something worth trying. All right, so first things first. as John Wells suggested, we'll need a low, which will equal 0, a high, which will equal array.length minus 1. And then here, so who can tell me why I should use for loop or why I should use while here?
Oh, whoops.
All right, Jake, we'll look at your code afterwards because I'm interested to see. Well, you can make sure that happens with for loop as well, Ryan. His question was, generally you want to use while when you need the code to run at least once to kick things off. And then he corrected himself, or no, that's do. Yeah, it's do while. While stops condition is met, for loop keeps going until it's complete. I want to say while because we want this to be log n and not like n. All right, solid, cool. So yeah, we'll want to use a while loop here because we don't actually know how many times we'll loop over the array, and we know that it has the target time complexity is O log n. What that really means is every time you run through one for loop, you want to cut the array at least in half where possible. So we'll do something like while low is less than or equal to high. We can loop over create. Oh, excuse me. That's Stacy. All right, never mind. Not Stacy. All right, so create middle to be initialized to average of low plus high. Have I lost anyone yet at this point? On this, if you are lost, tick the check box. Otherwise, hit the X. All right, a pretty solid response out of the CS1 class. All right. Why are we making a middle? You'll see in a second. We're making a middle because we need to chop our array in half every time. We'll get to there in a second. Pretty much, it's pretty much binary search, except we're doing it by index. So, check if array bracket middle is equal to number. If so, return middle. No worries. All right. And then what we can do here is if array bracket low is less than or equal to array bracket middle, then we can check if array bracket low is less than or equal to number, and number is less than array middle, we can set the high to equal, oops, there we go. If that set high to middle -1, else we'll set low to equal middle +1. And then we can also do else here. Else if array bracket middle is less than number and number is less than equal to array bracket high, we'll set low to equal mid +1, else high equals mid -1. All right, and then at the end of all that, return null. So if this while loop ever breaks, because low goes higher than high, or high goes lower than low, either or, you will return null because you've searched through the entire array. All right, cool. Anyone have any questions? No? Solid. Cool. All right, let's code it out. Cool. Let low equals 0. Let high equals array.length -1. And then while low is less than or equal to high, const mid is equal to math.floor of low plus high, parentheses, divide by 2. If array bracket mid is equal to number, return mid. Cool. All right, and then if all right, I lost my train of thought here. So let's see, we did that, and then if array bracket low is less than or equal to array bracket mid, if, and you'll have to forgive me, this is code that I'd written a while ago, I think. So it might be a bit convoluted. All right, so if low, mid, and then if array bracket low is less than or equal to number, and number is less than array bracket mid, high equals middle minus 1. Else low equals mid plus 1. There we go. All right, and then my next if statement goes just the last case, which is the opposite. Break it down. Else, if array bracket mid, then number, and number is less than or equal to element bracket high. All right, we'll clear it up in a minute, or we might just use Jake's code, because that could be definitely more efficient. Okay, I'll explain it in a minute. Let me check to see if this code works first, or if I need to refactor everything. Huh, element array. Cool, all right. You've lost track of what the code is doing. All right, let's see if we can't refactor it. All right, cool. So let's go through it real quick. What the code is doing here is let low equals 0. Actually, I don't need half this if statement, do I? So else if. Nope, I definitely need it. Yeah, this code only works when your pivot is on the point, which might not be the most efficient way to do it. Jake, you want to share your code? Oh, okay, cool. I have a separate function for a binary search and search for the pivot, which is 0, but there's some cases which doesn't work, like 1, 2, 3, 4, 5, 6, 0. Code doesn't handle that right now. Okay, cool. Yeah, the code only works when, it only ever returns the number when it finds it in the while loop. Let me see if I can't write this more efficiently. Constructed array search equals array num. All right, so I need to let low equals 0, let high equals array.length -1, while low is less than or equal to high. Sorry, this is going to be stream of consciousness thinking for a minute. So while low is high, I can find middle. And then with middle, I can, if middle is on the dot, then I can return it. Otherwise, I want to check to see if, so I do need to see if low is greater than, no, if low is less than middle, then I can check to see if low is less than medium, then I can check to see if low is less than target, and if target is less than medium. If both of those cases occur, then that means our number is in the lower half and we need to lower our high to the bottom half. Otherwise, we need to bring the lower up to the top half. And then in the other case where middle is higher than target and target is less than high, we can set low to greater than middle. Otherwise, we can set higher to the, okay, no, my code definitely is necessary to be the way it is. So, all right, let low is equal to 0. We know what that does. We let high equals array.length -1, which is the last item in the index. So while the index of low, low is going to be the index of our array, while this index is less than this index, which means we're bringing it by half every time, like we're shrinking it in half every time, until low becomes higher than high. We're going to keep running this. And then we first create a middle target, which is the floor of low plus high divided by 2, which is average. And then if array middle is the number, then we return the middle. Otherwise, we can check to see if the number at low is less than the number at middle, then what we also need to see is if array at low is less than our number and the number is less than middle, we can bring the high down so that we can bring it from the high side. So this side, this side would be high. We bring it down to half, and then we can half it each time, either by moving the left in or the right in until we get onto our number. Otherwise, in the opposite case, if array.middle is less than our number and our number is less than the array at high, we can set the lower half up to the middle plus 1. Otherwise, we can bring our high down to middle minus 1, which shrinks the array until we get to our number, either by getting it in the middle or by having it as the only number in our array. So, does that make sense? I realize that was stream of consciousness. Do I have any questions? That does make sense now that you awesome. Awesome. Okay. Cool. Cool. I'm glad that cleared that up for you. Any questions? Anyone want to share their code after I try Patrick's edge case? Cool beans. So first we're going to check to see if it returns null, and it does. And then if we want the number 3, it returns 0, 1, 2, 3, 4. Cool. So that would not be an edge. That should be a test case, but it is not an edge case. Does anyone want to share their code? Are we actually cutting over into sprint review time or anything? Calendar. All right, cool. We're cutting a bit into project time. All right, if there are no questions, Jake, you want to show us your code real quick? No worries if not. Does anyone else? All right, cool. All right, so let's change that array back to that. We're going to console log, or we're going to comment out that whole thing. Cool. So Wes, I definitely want to see a recursive solution. All right, so first things first, find the pivot. So just off the bat, we know that we lose efficiency because we do have a while loop in here already. And so you're basically calling binary search tree up to twice. So you would be doing O log n times O log n. Or O log n times log n. So I think that'd be actually O of n. No, never mind. I don't know my math. Cool. All right, let's take a look at Wes's code. Cool. All right, so const root is equal to array.reduce. So, all right, so he's finding 0 as well. So we already have an O of n here. And then we have binary search. So you have, so this solution appears to be n log n, which is n times log n, which is slightly worse than n. So let's see. Oh dear. Cool. So n times log n is greater than log n times log n. Nope, that's not what I'm looking for. So I can't tell you off the bat which one is higher versus which one is lower, but you did miss the target, but I do like to see the way you think. But it seems both of you found the target or started to find 0 first. All right, cool. Any questions left? Okay, cool. Let's take a look at Sarah's real quick, and then we'll stop at 40 or 42. Cool. So function binary search, nums target low high. If target is low, return high. Let middle, if let middle. If target is equal, return middle. Else if do binary search. Cool. Yeah, that's pretty efficient way to do it. Actually, it's recursive and binary search. Cool. Yeah, that's a recursive solution. Not sure which one is more efficient. Oh, wow, cool. Okay, I missed this top half. All right, cool. Yeah, he's right. It should show the location. No, it shows the location. That's 5. All right, cool. I'm going to end the recording here. Thank you, guys, and I will catch y'all around.